In addition to the most obvious hazards from firefighting, such as the smoke, flames and heat, we need to be aware of additional hazards during the firefighting process and take steps to reduce or eliminate the risks from them. Heat exhaustion is one of the least obvious personal hazards. Firefighters need to wear a heavy insulated fireman's outfit to protect them from the heat of the fire. However, they will get very hot inside the suit, and this can lead to dehydration. The humid atmosphere also means crew members do not lose heat through sweating. To protect crew from heat exhaustion, it's essential to monitor the time a person spends in a fireman's outfit and firefighting with a full SCBA set on. Realistic drills prepare the firefighter for wearing all the equipment and feeling the effects of it. When firefighting, it is also essential that you drink water to stay hydrated. Carbon dioxide released into the space to fight a fire lowers the oxygen content and will not support life. All crew, particularly those in the engine room, must know that when a CO2 alarm goes off, the space should be evacuated immediately. The CO2 must not be released until all crew are accounted for, and only on the master's orders. Firefighters must consider the steam that is produced when water hits hot surfaces, as this will burn exposed skin. For this reason, there should always be a proper fireman's outfit available with full body protection. Realistic training also prepares a person for a steam cloud that is produced when water is sprayed onto a hot surface. Guidance should also be given on using water spray rather than a jet of water, as this reduces the intensity of the steam produced. Water sprayed onto a fire will cause gases and smoke to spread away from the fire. So ventilation flaps should be closed and the air supply units should be stopped. If possible, the vessel should be turned so that the smoke and gas blow away from areas where the crew are located. Another hazard is that the air supply may run out or the SCBA may fail. Wearing an SCBA set for a realistic time allows the wearer to gauge their air consumption for the duration of firefighting. A drill should emphasize to the wearer that when a warning whistle sounds, the wearer should already be out of the space. It is not a sign to return to safety, as there may not be sufficient air left to do this. The wearers of self-contained breathing apparatus should practice various operations to assess their rate of consumption. This will vary with the amount of work the wearer is doing, the level of training, personal fitness, and the amount of stress the wearer is under. On average, a person uses 40 litres of air per minute. If a BA set has a cylinder pressure of 300 bar and the whistle sounds at 55 bar, there is 245 bar of working pressure. Experience with fires on board shows that the level of air used to get to the fire seat is the same as that needed to return. The rest is used for firefighting. Air use must be monitored at all times. If a fire is out of control or entry should not have taken place, there is a danger of being overcome by fire. There are two protection methods to stop this from happening. If a risk assessment shows that a fire is extensive, entry should not be attempted. Secondly, firefighters should always work in pairs as a minimum. This ensures that there is always a buddy to assist or raise the alarm. There should also be a lifeline that acts as a guide back to the outside if the firefighter becomes disorientated. There are a number of other hazards that can occur due to the actions taken when fighting fires. Stopping ventilation to a coal cargo can cause methane gas to build up. When using opposing streams of water, a jet can push smoke and flames away from one firefighting team towards another. Chemical fire suppression agents mixing with other chemicals can produce a dangerous gas. If dangerous goods are carried and the incorrect extinguishing medium is used, there is a real danger of making a fire worse. When chemicals are carried, it is important the correct information is available with regards to the type of extinguisher medium to be used. A fire hose discharges a lot of water. The flow rate is dependent on the hose diameter, the pressure in the line, and the type of nozzle in use. SOLAS requires that there should be a maximum discharge rate on certain types of vessels of 140 cubic meters per hour. At this flow rate, 2 fire hoses can deliver 150 tons of water every 30 minutes. 4 fire hoses can deliver 300 tons of water every 30 minutes. On some vessels, the flow rate is significantly higher, but this can make a hose more difficult to handle. Depending on where the water is being directed, some may go overboard, some become steam, but some will stay on board. The additional weight of water used to fight a fire can adversely affect a vessel's stability. At the very worst, top weight and free surface effect can result in a capsizing lever. This is why stability should be regularly assessed during firefighting operations. Any accumulated water should be allowed to drain away or be pumped straight overboard. In an emergency, the safety of the ship and crew come first, and there is provision in MARPOL that allows us not to have to discharge all of the water through the oily water separator. Obviously, we still need to take all reasonable steps to avoid pollution. During a fire, there are a number of stored goods that need to be considered. These include such things as paints and thinners found in the paint locker or storeroom, drums of grease and oil lubricants, and cylinders containing compressed gas such as LPG, oxygen, and acetylene. There will also be dry combustible stores, cleaning room stores such as boxes of aerosols which might use flammable propellants, and other combustible stores. Some dry cargoes present particular hazards. On a vessel carrying coal with a fire in the accommodation, steps have to be taken to stop the fire spreading to the coal. Boundary cooling is an effective way to do this. Any dangerous cargo on board should always be treated in accordance with the IMDG code. Some items, such as phosphorus, will burn if the product is exposed to air. Lithium will burn vigorously if exposed to water and air, and magnesium will burn underwater. Any flammable hydrocarbons on board should normally be stored well away from the accommodation. There should be a plan to remove them from a fire location or prevent the fire from getting anywhere near them. Cylinders containing compressed flammable gases are very dangerous, as they can explode if they get heated. This is known as a boiling liquid expanding vapor explosion, or a BLEVE. It causes the pressurized container to disintegrate, causing the sudden release of gases to erupt into a ball. Boundary cooling and direct cooling can be used to cool pressurized containers. If we can start this before heat builds up, so that the fire party is not at risk. Here is a reminder of the main learning points from this chapter. The risks to the firefighting teams should be properly assessed and minimized or reduced before committing teams to fight a fire directly or enter a space affected by fire. The stability of the vessel must be checked and maintained when using water to fight a fire. Additional risks can come both from hazardous goods and some of the ship's own stores, such as cylinders containing compressed gas.